Slopes of tangents. A graph of the cubic function f of x is equal to 2x cubed plus 5x squared plus x minus 3 is shown. So this has an x cubed in the function, and it is the highest power of x. So we have a cubic function which is an S-shaped graph. And a cubic function, so a function with an x cubed in it, has two turning points. So we can see the graph turns here. So this is its maximum. And we see the graph turns here also. This is its minimum point. The tangent to f of x at the point 0 minus 3 is also shown on the diagram. So a tangent is a line that touches a curve at one point. So the red line here is the tangent, and this is the point 0 minus 3 where it touches the graph. Part 1. Write down f prime x, the derivative of f of x. So we want to differentiate f of x. So f of x is equal to 2x cubed plus 5x squared plus x minus 3. So it's important to note that x is really 1x. So to differentiate a function, we bring the power down in front and we reduce the power by 1. So to differentiate 2x cubed, cubed is the power, so we bring the power down in front. So we say 2 multiplied by 3 is 6. And we reduce the power by 1. And 3 minus 1 is 2. So we get 6x squared. Next we want to differentiate 5x squared. So again we bring the power down in front. So we get 2 multiplied by 5, which is 10. And we reduce the power by 1. And 2 minus 1 is 1. So we get 10x to the power of 1, which is really just 10x. Next we want to differentiate 1x. So since we don't have any power, we can just cross off the x. So we just bring down the 1. And to differentiate minus 3 with respect to x, well, minus 3 doesn't have an x, so we just cancel it out. So the derivative of f of x, which is 2x cubed plus 5x squared plus x minus 3, is f prime x, which is 6x squared plus 10x plus 1. Part 2, hence, which means using your previous answer. So use your previous answer. Hence, find the slope of the tangent to f of x at x minus 3. So hence means using your previous answer. So in our previous answer, we got the derivative of f of x. And the derivative of f of x, or f prime x, is 6x squared plus 10x plus 1. So we worked this out in part 1. So to find the slope of the tangent at a particular point, we substitute the x coordinate, which is this 0 value here, of the point into the derivative. So the derivative is 6x squared plus 10x plus 1. So we swap each of those x's there highlighted in yellow for 0, but we have to have brackets around them. So we substitute in the x value, not the y value. We do not sub in the y value, it's only the x value. So we end up with f prime 0 being 6 times 0 squared plus 10 times 0 plus 1. 0 squared is 0 and 6 times 0 is 0, so that just cancels. 10 times 0 is 0, so we're just left with 1. So f prime 0 is equal to 1. Therefore, the slope of the tangent to the curve at x is equal to 0 is 1. So here we have our x-axis, and here we have 0 on our x-axis, and that is where the tangent is touching our curve, and we see that it is the point of 0 minus 3. And the slope of this line, or the gradient of this line, is 1. Part 3. Find the equation of the tangent to the curve at 0 minus 3. So the equation of the tangent, well, a tangent is a line. So if we want the equation of a line, we have to go to our formula book on the coordinate geometry page. So we go to our contents page and we look up coordinate geometry. And on the coordinate geometry page, there will be a formula that is y minus y1 equals m times x minus x1. And this formula here is the equation of a straight line. So we're going to use this formula to come up with the equation of the tangent line. So the equation is like the rule of the line, or the formula for the line, or the name of the line. And it has to be at the point 0 minus 3. So we're going to label our point x1, y1. Now we worked out in part 2 that the slope was 1. So we label m as 1 because m represents the slope. And then we sub 0, minus 3 and 1 into our formula for the equation of a straight line. So we bring down the y, we swap y1 for minus 3. It's important that you include the minus. So we have y minus y1, so we have y minus minus 3. Be very careful here, some people can forget the second minus. Now obviously if this did not have a minus, we'd only have one minus over here. But because there's a minus in the formula and a minus in our y value, we have two minuses. We bring down the equals. We swap the m for 1 because that was the slope that we worked out in part 2 of the question. We bring down the bracket and the x and the minus. We swap x1 for 0 and we close the bracket. Now y minus minus 3 is really y plus 3 because a minus stuck onto a minus is a plus, or a minus multiplied by a minus is a plus. And we still have equal to 1 times x minus 0. Now 1 times x is 1x, or just x, and 1 times minus 0 is 0, so we don't need to write that down. So we have y plus 3 is equal to x. So what we're going to do is bring the plus 3 over the equal sign, and it becomes minus 3. So we get y is equal to x, or 1x minus 3. So this is the equation of our tangent. And usually it is in the form of y equals x plus c. And it's usually in the form of y equals mx plus c, but in this case our m is 1, so we just have x. So y equals mx plus c, this is the equation of a line, and it's also in our formula book, and you'll find it beside this formula in our formula book. And it's just the format that we usually write lines in. So we usually have y on the left of the equal sign, the slope stuck onto the x, so some number, it could be 2, it could be minus 3, some number stuck onto x. In this particular example, it's 1, so we just forget about it, we just call it x, but technically we know this is 1x because we had a slope of 1. And then we have plus c at the end, so we have the constant at the end, but it doesn't have to be a plus. So it's just the number without an x stuck on. So in this case, it's minus 3. So y equals x minus 3 is in the form of y equals mx plus c, which is the form of the equation of a straight line. Or what we can do is bring everything over the left of the equal sign. So we'll have our x, our y, and our constant all equal to 0. So we have x minus y, because we're going to bring this y over the equal sign, minus y, minus 3 is equal to 0. Find a point on the curve y equals x squared minus 8x plus 21, where the tangent to the curve has a slope of 4. So there's no mention here of differentiation. We're not asked to find f prime x or dy dx. But when tangents, curves and slopes are mentioned, we want to start thinking differentiation. So we take our curve y equals x squared minus 8x plus 21 and we differentiate it. Because when we differentiate it, we're going to get the slope of all tangents to the curve. So the rule is we bring down the power in front and we reduce the power by 1. So we have x squared, so we bring the 2 down in front and we reduce the power by 1. So the 2 comes down in front, we get 2x, and 2 minus 1 is 1. So we get 2x to the power 1, which is just 2x. Next, we want to differentiate minus 8x. So since there's no power stuck onto the x, we can just cancel out the x. So to differentiate minus 8x, we just get minus 8. And to differentiate 21 with respect to x, there is no x, so we just cancel it. So the derivative of x squared minus 8x plus 21 is 2x minus 8. So this is the slope of all tangents to the curve. Now, the slope of the required tangent to the curve is 4. It said in the question, we want the tangent to the curve, which has a slope of 4. So what we're going to do is let our slope, which is 2x minus 8, equal 4. So if it had said where the tangent to the curve has a slope of 5, we would let our slope, which is our derivative, equal 5. If it had said where the tangent to the curve has a slope of minus 8, we would have let our derivative equal minus 8. Okay, so we're interested where it has a slope of 4, so we let our derivative equal 4. And then we just solve for x. So we start off with a single number, which is minus 8. We carry it over the equal sign, it becomes plus 8. And 4 plus 8 is 12. So now we have to get rid of the 2, and the 2 is stuck onto the x, so we're going to have to divide by 2. And if we divide by 2 on the left, we have to divide by 2 on the right. The 2's will cancel, so we're left with x on the left, and 12 divided by 2 is 6. So the slope of the tangent to the curve gives us an x value of 6. And this is specifically when the slope is 4. So, for example, if the question had asked us for the tangent to the curve with a slope of 5, we would have come up with a different x value. So we know that our x value is 6. Now we need to find the y value. We need to find the y coordinate. And we need to find the y coordinate when x is equal to 6. So what we do is we go back to our original function, which is y equals x squared minus 8x plus 21. So that was given in the question. Because remember, we're asked to find a point on the curve. We have an x value, now we need a y value. But you must substitute your x value into the original function. So we take each x value here highlighted in blue, and we swap it for 6 with brackets around it. You have to have brackets. 6 squared is 36. Minus 8 times 6 is minus 48. Plus 21. And 36 minus 48 plus 21 gives us 9. So we get a y value of 9. Therefore, the required point is 6, 9. An x value of 6 and a y value of 9. So we were asked to find a point on the curve of y equals x squared minus 8x plus 21, where the tangent to the curve has a slope of 4, and that point is 6, 9.